Morning, can we start?
Morning. Yes, we can.
Okay. So last time we're discussing the hyperbolic paraboloid. So let's just recall what we discussed and clarify anything that may have remained. So hyperbolic paraboloid. So we said it has got general equation x squared over a squared minus y squared over b squared is equal to z over c. So this is the general equation. And I did a sketch. How did we sketch this? So let me see if I can do it again. So we have then okay. To the axis, so this is the Z. Then you have the Y and the X. Yeah. So this is the general thing, and I think we ended up on discussing some elements to do with orientation. So to help clarify on that, let me share the screen. I found a very nice website, which is sort of interactive. You can changing your values of X and Y and see what is happening. So let me try to share the screen.
That's class.
And see if that will work. So I want to go to my browser. Which option should I go for? Screen, eh? Let's see. So are you able to see anything?
Yes, sir.
Yes, sir.
Yes, sir.
What can you see?
Which seems to be an hyperboloid.
Yes. So let's do this. So this is hyperbolic paraboloid. Why do we have feedback? Can you mute your mics, please? So this is a hyperbolic paraboloid. It has got equation Z is equal to x squared minus y squared. So if you relate it to the general equation, then your A is 1, your B is 1, and your C is 1. Okay, so let's see if we can do another view. Okay, this is the view. And this is the solid view. Okay. Are you able to see how it's changing?
Yes, sir.
Okay. So last week, there was something I wanted to explain about cross-section area. So I'll explain it using this interactive thing. So what is going to happen, we're going to be fixing our Z, and then fixing our Z for different values, and then see what is going to be happening. So I'll be changing my Z. So again, the equation is Z is equal to X squared minus Y squared. So look, let me change my Z. So that plane, have you seen that plane which is appearing? That is the plane Z is equal to -4. If I keep moving this plane upwards, let's see. I go to Z is equal to -3. You see that the intersection between the hyperbolic paraboloid and this plane is an ellipse. We go to 2, still get an ellipse. 3 at 1, an ellipse. At Z is equal to 0, we just get 2 lines which are crossing each other, which is what we expect there. Then going up, we still get an ellipse, only that the orientation has changed. So when Z is greater than 0, the orientation of ellipse. So, yes, please. Yes.
An ellipse or
hyperbola. Hyperbola, sorry, not an ellipse. I'm sorry. It's an hyperbola, yes. Hyperbola, very good. I'm so sorry. So as when Z is greater than 0, you still get an hyperbola, only that the orientation is in the X. It's seated in the X. When you're below there, you have hyperbola, which is oriented in the Y.
Sir,
I don't know if you can see clearly. Yes, please ask.
is it possible you can turn the orientation we see it from the top view? I'm failing to, yeah.
Okay, let's see. So I can change this like this. So I think this is in the Y view. Is this what you wanted?
Isn't that the bottom?
So so this is the side. So I don't know which view you're asking for.
Viewing it along the Z axis.
Yeah, this should be the top like this. This is the top. If then viewing it along the X like this. So I don't know which one you're looking for.
I think the bottom was better.
The problem is I don't know which one is the bottom.
I think it was okay the way it was initially.
Okay, I think yeah, this is a better view because it's like this is like the horizontal view. So yeah, so you can be changing your z-axis and seeing what is happening. Sorry, okay. So when you're changing your z, then you get this horizontal cross section, which is a hyperbola. What happens if you fix the x? So notice that in that equation.
You need me agent?
Can you mute your mics, please? Whose mic is on? Okay, so there's the equation again is Z is equal to y squared minus x squared minus y squared. Notice that when we fix y, the equation we get is a parabola with variables x and z. So what happens if we fix y? So we get a parabola. So let's see what's going to be happening. So I'll be changing my y. So let me change my y. And this is what is happening. So I'm shifting. So this plane is y is equal to -2. As I keep shifting it, you see I'm getting a parabola as my cross section. Parabola at y is equal to 0. I still get this parabola. There, y is equal to 1, and so on. Then the parabola gets bigger and bigger as you go down there. If you fix your x, you still get the parabola. So here I'm fixing my x now. This is x. The plane you can see now is x is equal to -2. I move it so that I get the plane x is equal to -1. And x is equal to 0, so I have that parabola, and so on. Does this help? Does this make sense? Do you have any questions?
Does help very much. Thank you.
Okay, let's see another one. So this one has equation. So the equation is here on top here. You can see the equation is z is equal to a x squared plus b y squared. So what we're going to be doing, so in this case, the way we write our general equation, so this big letter a is equal to 1 over a squared, the small letter a. So they've just written this big letter a as a coefficient, and with this equation you can relate it to your small letter a. So this is the view. So this is how it looks like. So this is how it looks like when you can see from the grid there, when your a is 1 and when your b is -1. So for it to be a hyperbolic paraboloid, you want that your signs are different, the signs of a and b. So in this case, our a is positive and our b is negative. That's why in the grid there, b is always negative, a is always positive. So as you see it now, my a is 1 and my b is -1. That's how it looks. So that's the view when you get your domain to be a square. By domain, I mean, square 2 inputs. When you get your domain to be a circle or a disk, this is how it will look like. So the domain, meaning your inputs, are coming from all the points within a circle. So let's try to change now. So let's go back to the square view. And then let's try to change. What's the effect of a being big and small? So let's try. So when a is, so this is when a is 0, this is what you get. So what is this? So when a is 0, you just
when
get
you view it from,
yes, go ahead.
When you're viewing from x-axis, it will be, I think, a parabola.
Yes, it's a parabola. So in this case, when a is 0, you remove the 0 thing, so it's just extended, just like we say for a cylinder. So the cylinder's equation, x squared plus y squared is equal to 1. But in space, you're just viewing, it's a circle in 2D, but in 3D, it becomes a cylinder. So same thing is happening here. So in 2D, it's a parabola, in 3D, it's just extended. But if a is not equal to 0, so let's be increasing a. As we are increasing a, see what is happening to the hyperbolic paraboloid. So this is the effect. And we end at a is equal to 3. So I go back to a is equal to 1, then change my b.
Sorry, sir. I wasn't there from the beginning. I'm not sure. Is this a book or some sort of interactive software? And is it available to all of us?
Yes, I can send you I'll send you, it's a website actually. So I'll send you the address, and you'll be able to view this also. So I just did this because I think it's easier to view. My drawings are not so good, so I thought this would be easier to understand. Is that okay?
Yes, sir. Thank you.
Okay. So my b here is -1. Let's change it to c. So what's happening. Let's go first to b is equal to 0. That's b is equal to 0. We eliminate the y completely. So again, we get a parabola in 3D. And then when we keep increasing our b, this is the effect. B is increasing. This is b is equal to -1, and so on. That's the effect. Okay. So this is all. This is I wanted to show you on the hyperbolic paraboloid. Are there any questions?
Yes, sir. I just want
Yes.
to see what happens when b is approaching 0 as well as 1 is approaching 0 at the same time.
What do you expect? That's a good question. What do you expect? That's a good question. What do you think?
I'm thinking it diminishes, but again, I'm not sure.
So look, when b and a is equal to 0, then the equation you get is z is equal to 0. So that's just the plane, the xy plane. So let's see. Let's get closer to 0. So b going to 0. So let's put b at 0.2. We approach a again, going to 0. See what's happening. It's getting flat. So that is when a is 0.2. When they are both 0, you get the plane. The z is equal to 0 plane. So good question. So the bigger these coefficients determine how stretched your hyperbolic paraboloid is, or how flat. So are you happy? Has your question been answered?
Yes.
Okay. Okay, so if that is the case, then we go back now and do with other, we can finish on other quadratic surfaces, then see if we can also get them on this website. See if we can be interactive. So I'll stop the sharing now and go back to discuss the other quadratic surfaces. So stop sharing. Yes. Okay. So let's make progress. So what have we done so far? We've done, let's see, one, we've done the ellipsoid. Then we've discussed the elliptic paraboloid. And then we've done hyperbolic hyperbolic paraboloid. So for me, I think this is a little bit it's more complicated anyway. The next one we want to do is the hyperboloid of one sheet. So hyperboloid of one sheet. And you understand very soon why that name. So let's see, what's the general equation? So the general equation is, so it's x squared over s squared plus y squared over b squared minus, so the z the z variable is negative, is equal to 1. And how does this appear? So let me try to sketch it here. So it looks something like this. Okay, then draw the axis. So z is coming out of there. So this is the z. The x is coming out of there. And the y coming out there. So this is the y. So this is the hyperboloid of one sheet. What do you think of my diagram?
Sorry, sir, your screen is,
Sorry?
your screen is not clear. Your screen is not clear, sir.
What could be the problem? Is it light?
I think it is network.
It looks
Yes,
clear on
clear
my
to see on
side.
my side.
Sir, your screen is clear. Maybe it is network. That's the problem.
Crystal clear.
Sir, I'm unable to get you.
Oh, sorry. I was even asking questions. So I was surprised no one was answering. Sorry, I inadvertently muted my mic. So thank you. Are you able to get me now?
Loud and clear.
Yes, sir.
Okay. So I was saying that the person was complaining about the screen not being clear. They can use they can log out and log in. So before I was asking, what do you think about my diagram? The diagram I drew, was it clear enough?
Yes.
No, sir.
Yes. Yes.
It was
Yes.
clear.
No,
Was
let me
clear.
explain. The way the lines that you drew for X and Y and Z, were they meeting outside the cylinder or inside, in between?
Inside.
Okay.
Yeah. Okay, anyway, let's look at a 3D vision, which we can. So this is how it looks like. Maybe let me try to rotate it a bit so that you see the other side. So this is how it looks like. This is an ellipse, a hyperbola in the home sheet. So that's the Z view. If you're viewing it along the Z axis, I think, like that. Are you able to see the rotations clearly?
Yes.
Okay. So this one has equation. So you get. So please mute your mics. So from the general equation, you get A is equal to 1, B is equal to 1, and C is equal to 1. You get something like this. So you notice that the horizontal cross section. So by horizontal cross section, what I mean is you're seeing how it's intersecting with the horizontal planes. The plane Z is equal to some constant. So your horizontal cross section is going to be a circle. So if you keep changing your Z or changing your
signal problem.
do you see what's happening? So this is the horizontal cross section. It is a circle. You go up there, still get a circle. So here the sizes of circle are reducing at 0. That's like the smallest circle and so on. So that is like when you're fixing your Z. If you're fixing your Y, what do you expect? What do you think you're going to get? Can anyone tell us what they would expect if you fix your Y? So we're looking at the horizontal cross section now. No one?
Could it be a hyperbola?
Yes, correct. It's a hyperbola. Because just look at the general equation. When you fix Y there, so you remain with the X variables. So X is positive, Z is negative. Then this just becomes a constant. So let's shift the Y and see what we get. So you see, getting those are parabolas, parabola, parabola. And then the parabola changes the orientation there. So here it was in the, is it in the X, the Z? The Z orientation, then it changes to X, and then goes back to Z, like that. If we fix the X, we still get the same. So the effect is the same, just the orientation is different. So that is the plane horizontal to the YZ plane. So this is the plane X is equal to 0. I can move it so that I get the plane X is equal to 2, negative 2, I get that. X is equal to negative 1, I get that. This is X is equal to 0, and so on. Okay. What else can we discuss? So this is another one. here, they're just telling us what will happen, the effect of changing your constants A, B, and C. So in this case, your A is 1, your B is 1, your C is 1, looks like this. Let's see when we change our A. So we change our A, what do we get? Becomes that, keeps getting smaller at 0. Well, it doesn't go all the way to 0. Then this is, as we increase it, so this is the effect of changing A. Bring it back to 1. Then I change B. So again, changing B. Increasing it greater than 1. Okay. How about C? So C, this is when it's this is when C is small. This is when C is equal to 1. When C is increasing, the hyperboloid of one sheet is getting smaller. Okay. So does this help?
So, sir, for C, when we're changing C,
yes,
as we reduce it to the negative side, it's increasing. Is it because of the minus Z squared over C?
Yes. Yes, exactly. Exactly.
Okay.
Yes. Yes. Yes, that's a good observation. Yes. So can I stop the sharing? We go back to the general equation.
Yes.
Okay. So the general equation. Yes, so this was the general equation. So let's discuss something. So this is just the general one. A lot of things can happen. So what we know about hyperboloid of one sheet is one variable has to be negative, not 2, but 1. So in this case, it's the Z. So if you had something like x squared over a squared, no, I meant to, let me go to the next page. So if you had something like x squared over a squared minus y squared over b squared plus x squared over c squared is equal to 1. This is still a hyperboloid of one sheet. So what do you expect? What's the difference between this and the previous one?
Its orientation will be in the y-axis for the circle's cross section.
Correct. So this is just oriented along the y-axis. So if you want one oriented along the x-axis, this x squared variable must be negative. What else can we talk about? We can also do translation. So like I said, translation is just moving either in the axis. So you can move left of the x-axis or right of the x-axis, left of the y-axis, right of the y-axis, or up and down. Up z-axis or down the z-axis. Okay. So if that is okay, so what we can say here, what is important is the variable, which is what we've discussed here. So the variable with the negative in front of it will give axis along which the graph is centered. along which the graph is centered, oriented. Okay. If that is okay, so I think this one is not so complicated. Let's discuss the hyperboloid of two sheets now. Of two sheets. So this is number 5. Hyperboloid of two sheets. So notice that in the hyperboloid of one sheet, when we put it in standard form, only one variable has the negative. So the difference between the hyperboloid of one sheet and two sheets is that in the case of the two sheets, two variables will have a negative in front of it. So if you have negative in front of the x, x squared, and negative in front of the y, then the other one is positive, is equal to 1. So this is the difference. If two variables, you put it in standard form, two variables are negative, then it's a hyperboloid of two sheets. And if only one variable is negative, it's a hyperboloid of one sheet. So this is the general equation. Let's give a sketch. So for this one, the sketch is the following. Someone has sent a message to say the screen is still not clear. So when I spotlight my video, I'm able to see what my screen is showing. So it looks clear to me. It's not
So
clear.
the screen is clear.
Okay, I think it's the network.
Yeah, so I think.
Sir, hello.
Yeah. Yes, please.
May I look at the previous page?
This one?
No. Oh, yeah, that one. No, the other one, sir. Where is the first equation for?
Okay.
Thank you. Wanted to see something. All right.
Oh, and I intend to post these notes on Moodle. Last week I tried, but Moodle was misbehaving, so I'll try this week. But I think
some of us can't access Moodle, sir.
So I'll post them on WhatsApp also. So I think there are some from last year, but I'll modify them to this year. So once that is done, I'll post them. Those who want to read for last year, just reading ahead, so there's no problem. Just modify them for this year, then I'll also possibly send some, look at the tutorial sheets and see if the questions are applicable this year. Okay, so I was trying to sketch the hyperboloid of two sheets. So let me sketch it first, then I include the axis. So it will look like this. So it will come in two, hence the name two sheets. Two surfaces which are disjoint. So it looks like a one sheet, but there are two disjoint. So where is your Z? So your Z will come out of there, the axis. And you to continue. Then your X. Then your Y. This is the negative Z axis. So maybe we can sketch it. So this is the negative Z. This is the X. Okay. So the equation is negative x squared over x squared minus y squared over p squared, then plus z squared over c squared is equal to 1. Okay, so what can we say? Yeah, so it comes as two surfaces, and we see that when z is equal to 0, so you can ask the question, does this surface intersect with the plane z is equal to 0 from the diagram? No. From the equation, you can see why. Because when z is equal to 0, what you get is that these variables minus, they're all squared, so they are positive, is equal to 1. This is not possible, because what you have on the left-hand side will be less than 0, right-hand side is 1. So this equation can't hold. So that's the reason you've got this gap. For all values of z, which make this equation impossible, there's this gap. Then at this point here, what do you think are the coordinates of this point? Are we able to tell from the equation? So where does this surface cross the z-axis?
Isn't it C?
It's CS. So this point is 0, 0, C, and this one is 0, 0, negative C. And it's easy to see from the general equation again, because as you know, along the x-axis, the x and y coordinates are 0. So if you equate,
So,
yes, please.
This C which we've put in those coordinates, is it the C which is the denominator of this z squared?
Yes, exactly. It's this C, yes. The value of this C determines where it cross the z-axis. So like I was saying, along the z-axis, all points on the z-axis have x coordinate 0 and y coordinate 0. So you can use that knowledge to equate 0 in this equation, 0 there, and then you solve. So what you're going to be solving, z squared over c squared is equal to 1, which is just z squared is equal to c squared, and so z is equal to plus or minus c. And so negative c, the negative part is there, the positive part is there. And then what do we see? In this case, what we see that the variable which is positive, which has plus in front of it, determines the orientation. In this case, the z is positive, so it's oriented along the z-axis. If it was y, which was positive, so for example, if you had something like minus x squared over a squared plus y squared over b squared minus z squared over c squared is equal to 1, you still get a hyperboloid of two sheets. The only difference is oriented along the y-axis. The y-axis. Does this make sense? Are there any questions?
Sir.
Yes, please.
In the case for the hyperboloid of one sheet, In the cross-section area for the circles, when you are decreasing, the circle is just becoming smaller. Does it ever reach a point in which it's like they make like just becomes like no circle?
No, in this case, no. So for a hyperboloid of one sheet, you never get a point where the circle is reducing, then it just reduces to a point, because here z is negative. When you take it the other side, it will be positive. So whatever value of z, your right hand side is always going to be positive. So this side always gives equation of an ellipse, and if a is equal to b, equation of a circle. But in the case,
I was
yes,
checking some graphs on the internet.
yes,
for the hyperboloid of two sheets, like they don't meet. Now, what type of graph would it be that forms a dot at the center, like they meet with the x? What type of graph would it be?
it's a cone. It's a cone.
On
Good
both
question.
sides?
Yes, yes, it's a cone. That's a good question. So what's if this is the equation of a hyperboloid of one sheet, if you want them to be meeting, or if you want your circles to be reducing to a point, just make this one equal, instead of 1 here, have 0, then you get what is called a cone. And you're going to see it soon. Have I answered your question?
Yes, sir.
Okay, so can we see this on that website? Let's see if it's there. We can quickly analyze it. Maybe it gives a better picture. And then when we do that, we finish off. So let's see. So it's a hyperboloid of two sheets. It's loading. Okay, yeah, so that's the general equation. Here, what they do, they just make a is equal to 1, b is equal to 1, and c is equal to 1. They get this equation. So this is the diagram of the hyperboloid of two sheets. So what we can do is shift the z to see the cross section, the horizontal cross section. So this is z. See, this is the z. Z is equal to -3. Going up there, that's the z. That's the z plane. There they only meet at a point. At z is equal to 1, they only meet at the point. At z is equal to -1 at the point. Between z is equal to -1 and 1, this plane doesn't meet the surface, the hyperboloid of two sheets. Then it starts again at z is equal to 1, meet at that point, and all others as the cross sections are circles like that. For the other cross sections, x, let's try x. So this is the x, the plane horizontal, the plane which is horizontal or parallel to the YZ plane. You just get hyperbolas, a little cross section area like that. Hyperbolas throughout. For y again, hyperbolas. Okay, let's see the effect of okay. So this is how it looks like when you get your domain. By domain, we mean you get your domain to be a square. So you're picking x and y on the xy plane to be a square. So you're picking values from that square, plugging them in, and then this is what it looks like. If your domain is a disk, then it looks like this, as we've sketched it. So what's the effect of changing A, B, and C? Let's start with A. So we are changing A. This is the effect, let's see. So that is A when A is equal to 0.6, when A is equal to 1.1, when A is equal to 2.1, and when A is equal to 2.7. Okay. Let's change the Y. So when Y is equal to 1, it looks like that. Oh, no, the B, sorry. So when B is equal to 0.6, 0.1, this is how it will look like. When B is equal to, this is 1.6, and B is equal to 2.3, and when B is equal to 2.4. I bring back my B to 1, somewhere there. I check the effect of C, first reducing it. This is how it looks like. So it's like flattens when you reduce the C, and then increasing it. So this is when C is equal to 0.7, when C is equal to 0.8, when C is equal to 2.4, 2.5, and lastly when C is equal to 3. Okay. Okay. So that's it. That's all I wanted to show you. So I'll stop sharing. Are there any questions on this?
Yes, sir. When C is equal to 0, are the two plates attached to each other, or there's still
That's a good
gap in
question.
between?
Well, that is problematic because C is in the denominator, so we don't want it to be 0, right? So we have a little bit of a problem there. But we can ask the limit as C approaches 0. I don't know what you get. It's a good question, but I don't know. It's a good question.
I was thinking you take C to 0 and then you change the orientation. We see what is in between the two hemispheres.
Well, it can be 0. Look at the equation of the two sheets. C is in the, so how do you make it 0?
Yes,
it can
I
be
know
0.
that.
So what should we do? So here, when it's close to 0, you see what you're getting. You're getting, yeah, it's just that the surfaces are like flattened, or these balls are flattened.
Let's see what's in between. Can you rotate it?
Or I rotate it, yes. There's still some space there. Still some space.
Sir.
So it doesn't become 1, I think. There's still some space. Are you able to see? So maybe when it's 0, you get two discs. I have no idea.
Yeah.
Yes, please.
I was thinking that the one you was talking about the C. I was thinking it can't. I was thinking C cannot be 0 because it's the denominator. Then the the whole thing will become distorted, like the equation of the hyperbola with is it hyperboloid with two sheets to become distorted, become something else.
Yes, very true. But he was just trying to see when it gets closer and closer to 0, what do we get? So it's like the limit as C approaches 0. What surface are you coming up with? So we can only imagine, I think. But maybe with a little bit of thought, you can figure out. It's a good question. Okay.
And then, sir, just for the sake of understanding.
Yes, please.
Is there a way of like eliminating one hemisphere, just using the same equation? Maybe we eliminate X so that we have just one hemisphere, maybe the upper hemisphere or the lower hemisphere.
Oh yeah, that's a good question. So yeah, so let me stop sharing. Okay, so if I understand your question, what you mean is the following. So let's make it simple. So this is the general equation as we have it, is this plus z squared over c squared is equal to 1. So to make things simple, let's make a, b, and c equal to 1, so that we get x squared minus y squared plus z squared is equal to 1. In this case, we can choose to make the z the subject. So if we make the z the subject, then we have z squared is equal to 1 plus x squared plus y squared. And then solving for z, we get that z is equal to plus or minus the square root of 1 plus x squared plus y squared. So these are two, we separate them. So we can say 1 is equal to z is equal to negative 1 plus x squared plus y squared. And the other one is z is equal to positive 1 plus x squared plus y squared. So actually these two equations, what they represent, this represents the part of the hyperboloid of two sheets, the surface which is on top. This represents the one which is on the bottom. So this is a very good question, and this is common. So if somebody asks you, for example, sketch this, it might not be obvious what this surface is, but having done this, you know, okay, this has something to do with the hyperboloid of two sheets. So in this case, this one, if I'm just to sketch this one, will look like this. So it's the one which is below there. So if you just want one, so this one is this one, then so this is the z, this is the x, this is the y. If you just want the one which is on top, they need to be this one here, like this. Has your question been answered?
Yes, sir, it has been answered.
Okay. Let's see. Are there any other questions? No. So we've done, also these are the major ones. What are we remaining with? We're remaining with the cone and the cylinder, which are so easy. So let me suggest, let's do this tomorrow. So after we're done with these, we can solve now specific examples on everything. So we'll look at, given an equation, how do you identify which of these quadratic surfaces it is, and probably give a sketch. So is that okay? Can we continue tomorrow at 14?
Yes, sir.
Okay. Okay. So if there are no questions, I'll end here and we meet tomorrow.